All right, so in this lesson, we're going to talk about how to name hypotheses, and there are two different types, alternative and null, and we'll talk about those. And we're going to talk about how to use hypotheses to test to see if claims are valid. So our big question here is how can we use statistics to test if claims are likely to be true or not? All right, so first we're going to start with what are hypotheses or writing hypothesis. Okay, so if we are going to write hypotheses, there are two different kinds. There is the null hypothesis where nothing changes from the original condition. So that one is written as H0, so H with a sub-0. And then we have the alternative hypothesis in which a change occurs, and we write that one as H with a little sub a down there. And let me do some examples of what those look like. Okay, so in this example, it says a car gets an average fuel economy of 34.6 miles per gallon, but a fuel additive company claims that their product will increase the fuel economy to 35.3 miles per gallon. So from this, we can write the hypothesis that the additive works if the gas mileage increases. All right, so that means my null hypothesis, meaning nothing happens, would be that the average fuel economy will remain 34.6. And my alternative hypothesis would be that this average, it will be greater than 34.6. So notice that it doesn't matter what it increases to. We're simply testing whether or not this measurement remains the same or changes. So in this example, we're going to take this concept a bit further. This problem says that we have a company that is claiming that so I'm going to write that this reports that their average price is $1.45. And a marketing company is going to sample 100 retail prices. So I would note that the sample is 100. The standard deviation of the prices is 20 cents, and the mean of the prices is 1.65. So the first thing we're going to do is write a hypothesis, the null and the alternative hypothesis. So in this case, the null hypothesis would be that the average is 1.45 as the manufacturers claim. So that is going to be, notice here, and I'm going to zoom in on this, and notice here that this is written as the mu equals 1.45. This would be the population standard deviation. If we look over here, it tells us that X bar is this is the sample standard deviation. So that's the difference between those two notations. Okay, and then we can also see then that the alternative hypothesis would be that the price is not 1.45 as they claim, but it is different instead. So for step 2, we're going to calculate some things. We're going to calculate our margin of error. So this is what we did in our previous lessons. We're going to do 2 times my standard deviation, which is 20 cents, over the square root of my sample size, which is 100. And that's going to give me a margin of error of 0.04. And then we're going to find our confidence interval, and we're going to get that by adding the mean plus or minus the margin of error. And so in this instance, we're testing the claim, so we need to use the sample mean that we've been given and the margin of error from that sample, which is going to give me a confidence interval of 161 and 169. And so using this, based on the claim, we kind of should be able to say, well, if my confidence intervals should be somewhere in the $1.60 range, and they're claiming that their average is 145, I think the conclusion is that the claim would be inaccurate. So then when you could write down is here at the bottom is that your conclusion is that the claim is outside of the confidence interval, so the claim is likely false. And this last part is just some wording that we tend to see in the statistics world. We can say that we can, and that I typed reflect, this should say reject the null hypothesis, which is to say that the price itself is actually not equal to $1.45. All right, so in this last example, we're going to talk about how to examine data from an experiment. So this is kind of going back to that first example we did talking about a car with a fuel additive that supposedly increased the gas mileage. And if you were to look at this data as it's given, you would see that on average it appears that without the additive, And with the additive, it looks like in a lot of these cases, the fuel economy increased. And so this says this is given with just 10 identical cars under the same conditions. So 10 identical cars under the same conditions, both with and without the fuel additive. So it seems like a pretty straightforward experiment. So if we were to compare these two, what we would do is we might find the mean of both groups. And let me actually take a step back. I would like for you to write down that the null hypothesis would be that the change does not occur. So if you subtract the means from the two different groups, they would be 0. And the alternative hypothesis would be then that if you subtract the difference between the two groups, that the mean would be greater when the fuel additive existed than when it didn't. So in this example, we are going to calculate the two means, which is what they've done here. So they calculated mean 1 and mean 2, and I would copy those down. And then you need to copy down this point here that the difference between the two is 0.76, which would then indicate that there is an increase. So exactly what this sentence says, the average increase was 0.76 miles per gallon greater with the additive than without. Okay, so the problem is that leads us to the question of, is that because of the additive? And so this is like the big question, and I would write this down. Is this due to the additive itself, or is it due to random variation? So for example, I know it says 10 identical cars, but the chances of 10 of the same car driving on the road, even under similar conditions, getting the exact same gas mileage is actually pretty low. That would be like saying a group of 10 runners are getting the exact same times. Okay, so then we need to do some things to test that. All right, so you should have those things written down. All right, so one way, I'm going to show you a picture and then I'm going to tell you what we need to write down here. So one way that we can do this is to re-randomize the data. So this, and you don't have to write this down yet, but this right here shows where they've just reorganized the groups. And I will admit, even when I read this, I thought, well, that doesn't make any sense. How is that going to help us? But I'm going to show you what that does. So we find the mean of the two groups, and we see that in this instance, it changes the difference from 0.76 to 0.08. Okay? And so this concept is that we can continue to re-randomize, not just one time, but maybe hundreds of times using some sort of computer program. And when we re-randomize, and this is what you need to write down, I'd put a star at the end of your notes, re-randomizing the data helps to show if the groups were unfairly made before the experiment, which would, I guess, indicate then natural variability. Okay, and we'll kind of revisit this concept again, but it's just the idea that if you keep mixing the groups up and rerunning the data, that you might actually see different patterns that would indicate whether the results you got made sense or if it was outside that confidence interval, kind of like we talked today and like we saw at the end of your assignment yesterday.